Hello, and welcome back to Learning with Lee. In today's episode, we are going to examine how inheritance affects our constructor, and how objects in general are constructed when they also have a parent object that also needs to get constructed when they are constructed. To begin with, let's take a look at a bit of a different thing than what we were looking at previously. Previously, we had been looking at stuff that was more related to Minecraft. However, in this case, you're going with a bit more of a generic thing that could be useful for Minecraft, could be useful for Skyrim, could be useful for D&D, or really any other RPG inventory management style system, and that we need to track items and various types of items, whether they be weapons such as this, whether they be armor, and we could even eventually add in things such as crafting components or blocks as items. But for now, all that we really care about is how we can construct it and how we have then children items. And the important reason why we would actually use this parent-child model in something such as items is that there are things that are very specific to a weapon that you don't need to care about if you're dealing with something that's armor, or that you're dealing with is redstone, or happens to be nightshade in case we're dealing with Skyrim or any other alchemical reagent there. So it's a matter of what there are is there's certain common features which suggest that there should be some common class or parent class. And then there happen to be specific unique features to each of those children classes, such as different weapons are going to need different types of attacks, and frankly we can even further subcategorize those into melee weapons and ranged weapons, such as what we have down here. However, those aren't as important as what we're dealing with these two. So let's examine item's constructor for now, because even though it has armor which is derived off of it, as well as weapon which is derived off of it, and derived is just another word for saying that it happens to be a child class of some other parent class. So saying that weapon is derived off of item is the same as saying that weapon is a child class of item, or that item is the parent of weapon. So item and its constructor are actually the exact same as if it had no children. And that's one of the nice and beautiful things about inheritance, is that something such as item, I can just create this without having to care whatsoever about any of its children. Now, its children are actually going to have to care about its constructor, but item itself, in case you view it sort of as a hill in which a parent is at the top of the hill, and each of the children is sort of on a tier down below it, anything that happens to be below you, you don't care about. You only care about what's at the top. So here happens to be item. It's perfectly fine how it is in here, just the same as it would be in case, and this is basically the exact same as how we would deal with something like link for its constructor, in which we're just setting the default values of the different items in there. And for that, I just am using some different static consts up here. And static basically saying it has a single spawn memory, and const is saying don't change that once it's assigned to it. Then over in here, in weapon, there's a few things that we have to change. And we don't actually have to touch the initial declaration of the constructor itself. Its initial declaration can be the exact same as it would be if it weren't derived off of item whatsoever. If I were to get rid of this, it would be declared in the same exact way. I'd probably need a few more fields to replicate the things that are currently in item. However, at the time being, that's not something I need to worry about. So, in weapon then, the major change now comes in over here, because this is actually not good enough. This is something that will cause it to complain. What I actually have to do, and to take a look over here, you might remember how we have this colon before item. Well, we're going to be reusing that colon again. So what we're going to do then is we're going to do colon, and then we're going to call item's constructor. And one of the things to note is that in item, I gave it defaults for all of its different values here. Same thing for weapon. So as in case I want to, I could give it this empty constructor and it just will fill it with defaults for me. And that's good enough for now. And frankly, we can even go a bit further with this. And let's say that in here I wanted to go with, rather than just having item alone be declared there, or end up being called there, we can also then assign things such as damage. And you can't use the equal operator here. You actually use these parentheses operator in order to basically go, I'm going to initialize damage to the argument damage that got passed in here. I haven't shown you this previously with constructors for one primary reason. And that's that in case I want to check whether or not this damage is a valid value, and I end up doing this up here, it ends up having some issues in terms of how am I going to check this. I could do some different stuff within here in terms of having some statements in here. So I could do something such as, well, I couldn't even do an if statement. I could do something along the lines of damage greater than 10, and then if so, use damage, otherwise use 10. But at the same time, that's really, really ugly, and it makes it somewhat limiting in terms of the amount of checks I can do to make certain that things are valid. It makes it much clearer and much cleaner to have each of these different fields initialized down in here, so as I can do things such as, so damage greater than 0, then we do this, and if it's not, and I could do something along the lines of damage equals 0, so that I have a minimum value of 0. Nothing is necessarily doing negative damage. Alternatively, I could actually see that as value for negative damage, so as I don't then have to create things that do healing as sort of its own side thing. It just is negative damage, and I just use a single thing for it. But that would be something to consider for the future, and that's the reason why, in general, I never showed you that alternate way of actually initializing these fields. Just because it's a bit less useful and a bit uglier in terms of when you start dealing with larger segments of code. So then, let's say that I want to specify an argument for item. There's a couple ways I can do this. The first off is that I can just supply them in order. You can see down in here, we have our name, weight, whether or not this item is stackable, and how many items can be in a stack. So let's start off with its name. Since it's just a weapon and we don't really know anything more than it, we can just refer to it as weapon. But let's then say that I want to adjust its stackability, and I don't want to touch anything else. I can't really go into here and make it so that I only do that one specific optional argument. What I would then have to do, and this happens to be an alternate way of doing this entire thing, is that rather than doing that, I can do underscore name equals weapon. And it's going to complain for now, and, well, it might not complain immediately. But that happens to be because, if we look over in here, name is private. At least when I build it, it's going to complain. But if I move it up to protected, then I can initialize it in here without having to supply the argument here. So if all I care about is the name and the stackability of it, and for now, let's just move these all so that they're protected, then I could just go, okay, I've done the name, and then I can end up doing, oh, it's actually complaining for right now, and that's probably because of the fact that I haven't built it yet, but, oh no, that's because I was going stackability as opposed to is stackable. But for this, I could then do this and say that I want it to be true or I want it to be false, because I never want weapons to be stacked. That happens to be a way of doing that without having to necessarily supply the specific set of items there, or having to end up have an overload of it, so as that alternatively what I could do then, in case I wanted to do that, is I could have something along the lines of only this, and then, well, non-weapon, an item, copy this guy, move this down, and I could then either reorder it, or I could delete the ones I don't care about, such as that, and then such as default weight over here, well, weight over here. Or I could just move those to the end of the list. However, then I would have to have one of these for every permutation of this constructor. As such, it makes a bit more sense in general that if you need to make those items protected unless you really, really do not want children classes getting access to those fields. For now, though, it's easy enough for us to just leave it alone in this sort of a manner, because when we end up actually creating one of these items, as typically would be done from either reading from a database or reading from a file, we're going to have all of these values for that particular item at once. It's not going to be the sort of thing of, okay, we need to do this, then we need to do this. We'll have all of these as a single set of arguments, and really we would have to have a different constructor for weapon that instead actually then takes in all of the items for item. And that's one of the important things to note. If I want to assign something that would normally be assigned in here to something that's in weapon, I would basically have to copy all of these, and I would have to then append them on to weapon. And for that, realistically, there's a few different ways you could do it. You could have weapon overloaded so as that it has multiple versions of it in here, in which it then has one that takes in everything, one that doesn't. And while this is a bit unwieldy in terms of how long this is, and typically one of the things that you'll see people do for this sort of thing is you'll do something along the lines of this just so as that you can see where it ends up looping around and how many items it actually has in it without having to go, okay, I need to scroll over now. So let's just say that we want to have that instead as another possible way that somebody could declare weapon. So in here, we can then just do this, put this here, and then have it defined in the same sort of manner. And really, this would end up being the exact same as the other two. The major thing is that we would want these guys in here, and then we would have to pass into item, basically, over here. And one of the common things you'll actually see people do is that either they'll enter this down to the new line, or they'll leave that at the end of one line and then do enter on the next line, and then they'll do item and they'll fill things in. So I'm going to leave that alone and not really deal with this portion for now. We can just pretend as though I never did that, because while that's important to understand, that realistically, if we ever want to actually assign something through, well, actually, yeah, let's leave it around. Because it is important to consider that if I need to assign something through weapon to item as part of the constructor, and that's the only way I can assign it to item, I have to have that as an argument to my weapon constructor also. Because otherwise, there's no way to really pass it through. Because you only end up calling a single constructor in somewhere such as intro.cpp. You don't actually end up calling a constructor for each item or each class that you're using. So in case we were dealing with this, you don't do something like this followed by item and then that. That is something that you just do not do, at least not in C++, C# or Java. That's not the way in which you end up doing this. What you have to do is you have to call a single constructor, and you have to pass through that constructor the arguments you want to pass through to the parent also. So as a result, in case I take a look over in weapon here, what I then have to take a look at is I'm taking a look at really, in here, what am I looking to do for these constructors? Is I can pass through the name, I can pass through the weight, stackability, max stack size. And part of what's complaining about over here is the fact that now it's ambiguous. Because both of these, due to the fact that they end up effectively having the same set of defaults, this one here is now redundant. It's no longer necessary. So we can get rid of that one, we can get rid of this one in here, and really just simplify it down to this one here. And that was because all of these items in here were optional. So if I passed in no items whatsoever, it would be valid for either one of them. If I even passed in just these first three items for either one of them, it would be identical. And once again, if I just pass in the default items for these, it would once again be identical for this situation here. And I can, to a certain extent, also control it, such as if I don't want things to be stackable as a weapon, I could get rid of that as an argument, get rid of that argument over in here also, and then say, okay, I just want to pass through guaranteed that it is not stackable. Because I don't want somebody to be able to just all of a sudden carry 50 swords on them, because that doesn't make sense. Or at least without having the inventory space to carry 50 distinct swords. So there's one final point about inheritance and constructors that I'd really like to drive home in this episode. And that has to deal with the order in which these constructors are used by memory, and why you need item out here, at least in C++. Some languages would say, okay, yeah, you can definitely call that from within here, and that's perfectly all right. However, it's a matter of what we're actually taking a look at for this, is that the problem that arises is that which needs to exist in memory first. Does weapon need to have its memory allocated first? Or does item need to have its memory allocated first? And you might be able to guess the answer and think about it in this sort of a manner. Could you exist if your parents had never existed, or their parents never existed? And the answer is that you would not exist without your parents existing, so, as a result, you need to end up having your parents generated, then you generated, or, in this case here, the parent class item gets its memory allocated first, then weapon gets its memory allocated second. And that is the way in which it ends up taking place, at least for C++, and for most languages. And what then is going to happen is that in case we say reach the end of scope where we're using it, and over here we're using this weapon here, and let's say I then go with, since it's a pointer and I made it onto the heap, I need to delete it. Let's delete I. Then for destroying that object, though, because of the fact that each of these sort of acts as a container, or each parent basically contains its children in memory, you need to destroy the smaller of those two first. So you need to destroy weapon first in memory, then item. It's a bit backwards, I understand, in terms of thinking about it using our earlier parent-child example. However, parents are going to get created first. Think of them as some sort of wrapper, or if you wanted to view it another way, think about it like a ship. In case you have a ship without its hull, it's just going to sink. Whereas in case you want to have all the different hallways and engines and the like inside of a ship, you're going to create the hull first, which is the parent class. And then within that, you're going to populate its children classes. So it's a matter of, within that, you're going to end up creating that outer shell of the parent class, then create the children classes. And then when you're destroying it or removing it, you're going to take the stuff out of the inside first, and then get rid of that outer containing shell. I understand that discussion was a bit esoteric. However, it is important to understand, and it's important to think about. So I would say just spend some time thinking about how this is for now, and in the next episode, we're going to even get more esoteric in that we're going to be dealing with a bit of polymorphism. It's not going to be a full-fledged coverage of the different things that are involved in it, but it's going to be an introduction to it, so as that you can understand some of why we have parent-child relationships beyond just the memory advantage that it gives us currently of being able to share these items here across multiple classes without having to replicate logic and information for them. With that, thank you very much for watching. Have a wonderful day.